So the question is the minimum energy required to launch a satellite of mass m from the surface of a Earth into a circular orbit at an altitude of 2r from the surface of a Earth. It's given that the radius of Earth is r and the altitude of a satellite is 2r, which means from the Earth's center, the satellite distance can be calculated as 3r. So here we are going to calculate the minimum energy required, which will be calculated by the formula E orbit minus E surface. Or else we can say the energy required to launch the satellite is the difference between energy in a orbit and the energy in a surface. So here the energy in a orbit will be equal to the sum of kinetic and the potential energy in the orbit. Similarly, the energy of a surface will be equal to kinetic energy at surface plus potential energy at surface. Here, it's known that the kinetic energy at the orbit is equal to gmm divided by 6r, whereas the potential energy at orbit will be equal to minus gmm divided by 3r. Similarly, the energy at surface can be calculated by using a formulas of gravitational field strength formula, whereas the kinetic energy at surface will be 0 because the satellite will be on a rest position at the surface of a Earth, whereas the potential energy at the surface will be equal to minus gmm divided by r. Now we can apply all the values in the energy required formula. So it will be equal to gmm divided by 6r minus gmm divided by 3r minus of gmm divided by r. When we are simplifying this, we will get the answer of gmm divided by r times of 5/6. So based on this, we can say the correct answer will be option C here.